Hi, in this video I will introduce Newton's law of gravitation. In 1687, Isaac Newton published his ideas about gravity after realizing that the same force that made objects fall towards the Earth's surface is responsible for holding the planets in orbit around the Sun. His key claims were: an attractive force acts between all matter in the universe, and the size of this force acting between two masses is firstly proportional to the product of the masses and inversely proportional to the square of their separation. So we can write this as F is proportional to the product of mass 1 multiplied by the product of mass 2. Sometimes we write it as a big M and a little m, sometimes we write it as mass 1, mass 2. We can also say that F is inversely proportional to their separation, where we use R to refer to separation. So combining these, we can say that F is proportional to the product of the masses divided by the square of the separation. Using the constant of proportionality big G here, we can write F is equal to big G, big M, little m divided by R squared. The constant of proportionality here, big G, is called the universal gravitational constant. Note that this is always a capital G and it should never be confused with the lowercase g that we use for gravitational field strength, which is 9.81 newtons per kilogram on the Earth's surface. Big G has a value of 6.67 times 10 to the power of minus 11 meters cubed per kilogram per second squared, but don't worry too much about those units. For example, what is the strength of the gravitational force acting between the Sun and the Earth? Well, to know this, we need to know four values: the mass of the Earth, the mass of the Sun, the distance from the Earth to the Sun, and our universal gravitational constant, G. So, applying Newton's law of gravitation, F equals big G, big M, little m, divided by R squared. We can substitute our values in to produce an answer of 3.57 times 10 to the power of 22 newtons. A quick final note: force is a vector, so if you're asked to calculate the force due to multiple gravitational fields, you need to work out each one separately using the mass and the separation from each planet and then combine them as vectors.